Now in this video basically we'll discuss a concept related to Lewis dot structure. So we'll write Lewis dot structure. So this video relates how to write Lewis dot structure. This is one of the important concept in organic chemistry as well as and chemical bonding chapter. So let us say I will give you some steps to find how to write Lewis dot structure. What are the steps? And the first step you will have, basically you have to decide the skeleton. So decide a skeleton. What do you mean by when I say a skeleton? That is the arrangement of atoms. So this is meaning of arrangement of atom. So this is the meaning of arrangement of atom. Let us say if I say molecule CH4, so what is the arrangement? In this case I will write C here, H here, H here, H here, H here. So this is the skeleton. There are some guide rules for writing a skeleton. What are the guide rules are? The guide rule is hydrogen will always be terminal atom. So you see there are, this carbon is a central atom, this is the center, so hydrogen is the terminal atom. So you see hydrogen in the terminal side and carbon is in the central side, so we call carbon as a central atom and we call hydrogen as a terminal atom in this case. So what is the guideline we have to writing a skeleton? The guideline is hydrogen is always a terminal atom. Hydrogen is always a terminal atom. Are you getting or not? So we have to always place the hydrogen at terminal. This is very easy because hydrogen forms only one bond, so we cannot put at the center, because if I put in the center this at least have more than one bond, but if I put the hydrogen in the center it is not possible because hydrogen forms only one bond. Now if I have two atom, generally more electronegative atom is put on the terminal and less electronegative atom is put on the center. So less electronegative atom is generally is central atom is treated as a central atom. Are you getting? So this is a central atom. Now you can see, let us say if I have CO2 molecule, if I want to write a skeleton, carbon is less electronegative than oxygen. If you know, you go from the, in the period you go from left to right, you will have more electronegative. So carbon is less electronegative, carbon will be treated as center atom and oxygen will be treated as a terminal atom, because carbon is less electronegative. So carbon is less electronegative and oxygen is basically more electronegative. So this is the guideline to writing a skeleton. So what is the first task? First task is decide a skeleton, and that is the arrangement of atom, that is the connectivity. And now how to decide this arrangement? First rule is hydrogen is always be a terminal atom. Hydrogen is a terminal atom. Are you getting? Always. And the next rule is less electronegative atom is a generally central atom. Now let us say if I ask what is the connectivity in case of NH3, what you will say? Of course hydrogen will be a terminal atom and nitrogen will be a central atom. If I say, let us say what is the connectivity of HNO3, so you can expect nitrogen will be here and oxygen will be here and oxygen will be here. So I have 3 oxygen, HNO3. So I have hydrogen should be a terminal atom, so hydrogen will be here and 1 oxygen will be here. So this is the connectivity for HNO3. So slowly this is also comes by practice. So if you do more practice you can write a skeleton easily. What is the next step? Count total valence electrons. So this is the next step, count total valence electron. What is the meaning of this step? Let us say I have H2. What is the total valence electron? Hydrogen has one valence electron. There are two hydrogens, so 2 into 1, and I have one oxygen. Oxygen has 6 valence electrons, so basically we have total 8 valence electron in this case. Let us say if I have NH3, what is the total valence electron? Nitrogen has 5, one hydrogen has 1, and 3 hydrogen I have, so in this case again we have total 8 valence electron. Now let us say CO2, carbon has 4 valence electron and 1 oxygen 6, so total we have 6 into 2 12 plus 4 16 valence electron. So this is the step number 2. Let us say you have H2SO4. What is the total valence electron? In this case you can have 2 hydrogen, 2 into 1, 1 sulfur, that is 6, and 4 oxygen, so 4 into 6. So total how many have? We have 2 plus 6 plus 24, that is the 32 electron we have. So this is the total valence electron we have. Now the next step is, so this is the second step, and third step what you have to do is connect atoms with at least one bond. Now you have written the skeleton, and you have also counted the number of total electron. Now connect the atoms with at least one bond. And so let us say what is the meaning of this. So let us say if I say NH3, I will have nitrogen, hydrogen, hydrogen. So now I have to connect this one, connect all these atoms at least by one bond. H2, if I have OH, connect this one. Are you getting or not? Now in this step, now let us say fourth step, what you have to do is find out rest of the electron. Basically this is a valence electron, so whenever I'm talking electron, so I'm talking about a valence electron. So find out the rest of the valence electron after making a single bond. So you see what is the meaning of this. You see, let us say NH3, we have said NH3 has 8 valence electron, and we also said make at least one bond. So this is bond. Now how many electrons have been used? Each bond contains 2 electrons, so there are 3 single bonds. So 3 into 2, basically 6 electron is used. So now I can say 6 electron is used. And how many electron I have? I have 8 electrons. So rest of the electron, how many rest of the electron I have? So find out the rest of electron. So we can basically find rest of electron, and this is equals to at minus 6 we have 2 electron. Are you getting or not? So now we have to put these 2 electrons as a lone pair. So now let us say put this as a fifth step, put rest electron as lone pair. And apart from this we have next rule. Let us say first decide this one and then we'll discuss. So let us say put this as a lone pair. So I have 2 rest of the electrons, so we can put 2 lone pair, 2 as a lone pair on the nitrogen, because now check the octet. Now finally check the octet of each atom for hydrogen. Check the duet, because hydrogen can have maximum 2 electrons. Check the duet, and you have to also, if octet is not, let us say in this case again, if octet is not complete, make double bond, double or triple bond from the lone pair. What is the meaning of all this we'll discuss, so no need to worry. Now let us say if you have NH3, now in this case nitrogen has 2 4 6 8 electron, hydrogen has duet, so this is over. So we have checked this duet in this case. Now we'll do some more exercises, and we will also go through this step. Let us say I have to write LewisDot structure of H2O. What is the first step? We have to write a skeleton. So we have written the skeleton for H2O. What is the next step? Count total number of valence electron. So 6 plus 2, that is total 8 valence electron. Now count at least by connect with at least by one bond. So how many rest of the electron we have? So rest electron we have, that is 2 into 2 4 is used, 8 I have, so 8 minus 4, that is 4 electron I have. This means I have to put these two electron as a lone pair. I cannot put these two lone pair as a hydrogen, because hydrogen cannot have more than two electrons. So now check the octets. Hydrogen has two, that is duet is complete. Oxygen, that is 2 4 6 8, octet is complete. Hydrogen duet is complete. So basically hydrogen has, this molecule is octet of each is complete. Now let us say if I have some another molecule CH4, we can write LewisDot structure. Carbon will be central and hydrogen will be terminal atom. So this is hydrogen, hydrogen. Total valence electron 4 plus 4, that is 8. Now we can connect by one, at least one bond. Now you see what is the rest of electron. So rest electron I have, we have used 2 4 6 8, we have 8, so 8 minus 8, that is 0. This means there is no lone pair. So in this case we will have no lone pair. You getting or not? Now let us say go for the next structure. Let us say I have NO2 minus. This is slightly tricky one. First you have to write a skeleton NOO, and now at least one bond. And what is the number of valence electron we have? 5 plus 1. 5 we have for nitrogen, oxygen we have 2 into 6, and 1 we have extra for negative charge. So basically we have total 6 and 12, that is the 18 valence electron. Now how many electron we have used? We have used only 4, so rest electron we have 18 minus 4, that is we have 14 of electron, that is rest. Now we have to place this 40 electron. We have to fast put these electrons on more electrons. So what we have to do is we have to complete the octet of more electronegative atom fast. So this point is also important. Complete the octet of more electronegative atom first. So you have to complete the electronegative atom octet fast. So you see oxygen is more electronegative. So I have 14. So we can place 2, 4, 6. And this is octet is complete 2, 4, 6, 8. And we can also complete the octet 2, 4, 6. So we have used 12 electron, 2, 4, 6 here and 6 here. 12. Now we have 14. So 2 rest of the electron still I have. So we can place these 2 electron on nitrogen. Now check the basically octet of each atom. Now if you see, octet of oxygen is complete, octet of this oxygen is also complete, but octet of this nitrogen is not complete. Octet of nitrogen is not complete, so octet in this case, octet not complete. So what we can do is we can try to make sharing of these two lone pair. What we can do is, if these two lone pair forms a bond between nitrogen and oxygen, this lone pair goes to form a bond between nitrogen and oxygen. So what we are doing, we are converting a lone pair to bond pair. So this is the case we are doing. So we are converting a lone pair. So we are converting a lone pair to bond pair. So let us say what will happen. So if I do this, I have 2 electron here, 2 electron here, there will be bond pair, nitrogen, and 2 electron is here, and oxygen we have this. Are you getting or not? Somebody can say, why are you putting this lone pair as a bond pair? Why not on this? You can always do that also. If you base, you can always do that one also. So you have NO2. So if you wish, you can convert this lone pair as a bond pair. If you do that, you will have nitrogen 2 lone pair. There will be bond pair, and 2 lone pair here will have, and you have oxygen. This is the case of. So these are the two possible resonating structures. So these two Lewis dot structure. There are two Lewis dot structure. This is also a Lewis dot structure. This is also a Lewis dot structure. And these two Lewis dot structures are generally called resonating structure. So this is a Lewis dot structure 1. So this is a Lewis dot structure 1, and this is, let us say, Lewis dot structure 2. Now these two structures are basically called resonating structures. So these two structure we can write resonating structures, and resonating structures are generally denoted by this kind of arrow. Are you getting or not? So these are two basically resonating structures. You see, we have to also find out the formal charge in this case. Finally, put the formal charge. Finally, if atom has formal charge, if atoms have formal charge, put them. So we have to finally put the formal charge. Let us say in this case nitrogen, what is the formal charge? 2450 formal charge. Oxygen 2467, it should have 6 but had 7, so this oxygen will have -1 formal charge. 246, oxygen will have 0 formal charge. Now 2467 -1 formal charge, this is 0, this is 0. You can verify yourself. So you see, for NO2 we have two resonating structure. One is this, and another you have another resonating structure, that is this one. This side you have single bond, and this side you have double bond. So you have this side single bond, and this side basically double bonds. So 0 formal charge, 0 formal charge. This side also 0 formal charge, and generally 0 formal charge does not need to be shown. So this is the case of NO2. There are two Lewis dot structure. Now let us say, if I say we have to write Lewis dot structure of C2H2, C2H4, first let us try. And now a skeleton, if I give you, carbon is basically, there are two carbon, this is treated as a central carbon, and there are four hydrogen, 1 2. You can basically make a symmetrical structure. This is also from hint, you can use symmetry. So there are four, so two carbon, two hydrogen will go to one carbon, and to another hydrogen will go to the another carbon, so you can use symmetry. So symmetry is also important. Now what you have to do, you have to connect by at least one bond. Now you count total number of electrons, so 4 into 2 plus 4, so we have 12 electron. So now what, how many electron we have used? 2 4 6 7 8. So sorry, 2 4 6 8 10. So we have used 10 electrons. So how many rest electron we have? So rest electron we have, that is 12 minus 10, that is 2 electron we have, rest of the electron. Now we can put these 2 electron as a lone pair, either on this carbon or on this carbon, both are equivalent. So let us put these 2 electron on this carbon. Now check the octet. This carbon has octet complete, but this carbon does not have octet complete, 2 4 6 only. So what we can do, so in this case octet is complete for this carbon, octet complete, but in this case octet is not complete. Octet is not complete. So what we can do is, we can convert a lone pair into bond pair. So convert lone pair into bond pair. Are you getting or not? So we can write bond pair as BP. So this is conversion. So now you will have here a double bond. This lone pair is converted into bond pair. So finally we'll have hydrogen, carbon, hydrogen, and then you have again hydrogen. So this is the structure. Can you try for this one? This is a again easy C2H2. Can you try for this one? This is again easy problem. Now we have two carbon. Use the symmetry idea, 1 and 2. And 2 hydrogen we have. We can put one hydrogen this side, another hydrogen this side. At least we have to form one bond. How many electron we have? Carbon into 2, 4 into 2 plus 2. So we have 10 electron. We have used 2 for 6 electrons. So how many rest electron we have? So we have 10 minus 6, that is 4 electron we have as a rest electron. Now we can put 4 electron, either 2 electron here and 2 electron here. If we basically can put these 2 electron at the same place, but basically it is okay if you do the vice symmetry. Now check the octet. This has only 6 electron, this has only 6 electron, 2 4 6 2 4 6. So what we can do, we can start forming, convert lone pair as a bond pair. That is, we have to form multiple bond, convert lone pair as bond pair. So if I convert this lone pair as a bond pair, let us say what happens, hydrogen carbon, then we have two bond, and then I have a lone pair here, and then I have hydrogen. Now check again the octet, but octet is not complete. This is 2 4 6 2 4 6. So this carbon octet is okay, octet okay, but octet for this carbon is not complete, not complete. Are you getting? So octet for this carbon is not complete. So what we can do is we can form these two lone pair as a bond pair. So if I do something like this, so again I have to convert lone pair as a bond pair. So if I do this, what will happen? I will have H C C H. Are you getting or not? So this is the structure of basically acetylene molecule. Are you getting or not? Now let us say we'll do some more exercises in some another cases, another chapter. Let us say if I say NO2 molecule, some odd electron molecule. So odd electron molecule. I have a molecule called NO. Now see what is the total number of valence electron. Nitrogen has 5, oxygen has 6, so we have total 11 electron. Now see, 11 is a odd number. Generally we have even electron, total electron is generally even, but now in this case we have odd number of electrons. So this means I can have a bond pair, I have to use 2 electron. If I use lone pair, this is also included 2 electron, but I have a odd, so this means there should be a single electron somewhere. So this denotes there is a single electron somewhere in the molecule. So there is a single electron somewhere in the molecule. Are you getting or not? So there is a somewhere single molecule, single electron. So you have NO, so let us say N and O connect by one bond. Now we have used 2, we have 11, so we have rest 9 electron. So rest electron we have 11 minus 2, that is 9. We have to first put the octet of more electronegative atom. So we have used 6. We still have 3 electrons, so we can place this 2 electron on NO. So this is a basically molecule NO. You can calculate the formal charge on oxygen 2467. Oxygen has a -1 formal charge, and nitrogen 2234. So this nitrogen will have a +1 formal charge. Basically overall molecule have 0 formal charge. Check the octet of nitrogen. Nitrogen does not have octet complete, 2 4 and 5. So what we can do is we can convert this lone pair into bond pair, so that now we can have octet complete of nitrogen. Now you check the octet. Oxygen has octet complete 2468. So formal charge is 0. But now in case of nitrogen 2467, so we have 7 electron. We cannot complete the octet of nitrogen anyhow because we have to have a lone electron. So not possible. So this is a case of this molecule exists, and this is the exceptional molecule, in which case octet of nitrogen is not complete, but this molecule exists. Octet of nitrogen is not complete. So nitrogen octet is not complete. Are you getting or not? That's why this molecule is very reactive. So this molecule is very reactive. So this is very reactive. And that's why whenever we have two NO molecule, basically they're dimerized. So you see we have one NO molecule and this is another NO molecule. Somehow if I get another NO molecule, these two molecule, basically this lone pair and this lone electron forms a bond. They form a bond and they convert into N2O2. Now this is molecule is N2O2. Are you getting or not? You see now nitrogen has octet complete, this nitrogen also octet complete, and this process is called dimerization. So they dimerize, this means two molecules becomes one. So odd molecules are generally very reactive and they dimerize. Now we have another odd electron molecule, that is NO2. So this is another example of NO2 is another example of odd electron molecule. Can you do this one? NO2, basically you can write NO2 at least one bond. What is the total electron? 5 plus 2 into 6, and this is 12 plus 5 17. So we have used 4, so rest we have 13 electrons. So rest we have, and this is 4, so we have 13 electrons. So we have to place 13 containing octet of oxygen is complete, 6 here and 6 here. Now we have only one electron, so we can place one electron here. Nitrogen does not has its octet complete, so what we can do is we can form a single bond from multiple bond from this side. So if I do this, what will happen? I will have oxygen here, I will have a double bond nitrogen, and this is oxygen. Now see, this is your NO2 molecule. Now nitrogen does not have octet complete, it has only 7 electron, but we cannot do anything. If I try to make one more bond, it will have 9 electron, and nitrogen cannot have 9 electrons, so that's why we cannot make this another bond. So some people can say, why you are making from this side, why not you are making a bond from this side? Okay, you can do that, and this will be another resonating structure. So if you make a bond from this side, you will have single bond this side but double bond this side. Now these two structure will be basically resonating structure. So these two structures are resonating structure. If you calculate the formal charge on this nitrogen, oxygen will have a formal charge of -1, nitrogen will have a formal charge of +1, this oxygen will have a formal charge of -1, and this oxygen will have a nitrogen will have a plus charge of formal charge of +1. Are you getting or not? So you see now NO2 molecule is again reactive molecule. So whenever I have two NO2 molecule, they can dimerize easily. So you have one NO2 molecule, you have another NO2 molecule, and they can dimerize and they can form N2O4. So this is N2O4. Are you getting? So this is your let me write here. So this is your N2O4. So this molecule is your N2O4. Now they can easily dimerize. So here you have 2 electron and 2 electron. Here you will have 2 4 6 8. Nitrogen has its octet complete. 2 4 6 8. Nitrogen has its octet complete. And now this will have a basically formal charge of -1. So this oxygen will have a formal charge of -1. This oxygen will also have a formal charge of -1, this -1, this -1, and nitrogen will have a formal charge of +1. So this is a +1 and this is a +1. Are you getting or not? So let me write again one N2O4 structure. I think all of you got this one. So NO2 dimerizes easily and it forms N2O4. So NO2, if you have NO2 and this dimerizes, that is 2 molecule of NO2, and this is forming N2O4. So if you see LewisDot structure of N2O4 is this. So this is your N2O4. This nitrogen will have, oxygen will have minus 1, this is plus 1, and this is your plus 1. So this is a case of odd electron molecule. There are some molecule that is called, basically does not follow the octet. Now there are some molecules that violate the octet. So octet expanded molecule. So there are some molecule which basically violate the octet. Let us say we have a first molecule is PCl5. Now phosphorus will be as a central electron, chlorine will be a terminal electron. So you should have PCl and this Cl at least connect by one bond. Now if you see total electron, we have phosphorus as 5 and chlorine will have 7 into 5, so that is the 40 electron we have. So we have used 5 bond we have made, so we have used basically 10 electrons. So how many rest electron we have? So rest we have 14 minus 10, that is 30 electron we have rest. So we can place them on 5 chlorine equally 6 electron on each chlorine. So 2 4 6 2 4 6 2 4 6. So chlorine has, now you can check the octet. Chlorine has its octet complete 2468. Important point is phosphorus has 10 electron, 2468 10. So phosphorus in this case, phosphorus has 10 electron, 10 valence electron, and this is basically violating the octet, that is expanded octet. This is okay because phosphorus has s orbital, p orbital as well as d orbital, so it can have 2 from s, 6 from p and 10 from d, so it can maximum have 18 electron, and that's why I can expand it octet. So if you see periodic table, first period you can have maximum 2 electron, second period you can have maximum 8 electron, and third period you can have maximum 18 electron, and the phosphorus falls in the third period. So this is the first, this is the second period, this is the third period, and you have nitrogen here, you have phosphorus here. So phosphorus falls in the third period, it can have maximum 18 electron. So element after the third period we can violate the octet. So for elements after the third period, after the third period third period we can always expand its octet. Are you getting? So we can have more than basically 8 electron. Let us say calculate the formal charge. Phosphorus will have 0 formal charge and oxygen will have also 0 formal charge. So this is the case of PCl5. You can do some more exercise of this kind. Let us say you have SF6 molecule. This is also a case SF, F, F and F. So you connect by one bond and F. So you have 6 fluorine. Now you see sulfur has 6 and fluorine has 7 into 6, so this is total 48. 7 into 6 42 and plus 6 48. So we have used 6 bonds, so that is 12 electrons. So we have 14 minus 12, 48 minus 12, that is basically we have rest of 36 electron. So we have 6 fluorine atom, we can divide equally 6 electron on each. So we can write, this is the LewisDot structure of SF6. So this is the LewisDot structure of SF6. Are you getting or not? In some cases, so this is about the LewisDot structure. In some cases you will have more than one LewisDot structure possible. In that case you have to try to minimize the formal charge and you have to see the best LewisDot structure is the one in which more electronegative atom has the negative charge and more electropositive atom has the positive charge. In case of, so we can use this as a rule in case of more Lewis-Dot structure, more possible, or you can say in case of more than one possible Lewis-Dot structure, more than one possible Lewis-Dot structure, Lewis-Dot structure, we have to select the Lewis-Dot structure that has lowest formal charge. Lowest formal charge. And if there is a formal charge, more electronegative atoms should contain negative charge. So if I have a more electronegative atom, it can contains negative charge, and if I have more electropositive atom, it should contain positive charge. We can explain this by one example. Let us say I have NCO minus, this molecule. Now of course carbon is least electronegative atom, this is a central atom, nitrogen will be terminal atom, and this oxygen will again a terminal atom. We can connect by one bond. Now let us count total electron. 5 from nitrogen, carbon will have 4 and oxygen will have 6, and 1 electron we have extra. So we have total 5 plus 4 9 plus 1 10 plus 16. So we have used 4 electrons. So we have rest how many electrons? So we have rest 16 minus 4, that is 12 electron. We have rest 12 electron. So we have to plus 12 electron, and we have to put the more electronegative atom octet first. So we can put 6 electron here. Now we still have 6. Now we can put this 6 on nitrogen. Now try to make the octet complete. Now we can complete the octet of carbon from this side, or one can do from this side also. Are you getting or not? So let us say both possibility. If I do from this side, I will have oxygen, this lone pair goes to form a bond pair, so I will have only 2 lone pair, and nitrogen from this side, so I will have, this is 1. Now carbon does not have a still octet complete, so what we can do is we can make a bond from this side. Basically there are many possibilities in this case you have. What are the possibility you have? So let me first write this one, so I can make a bond from this side. So if I do this, I will have 2 4 and carbon, and then I have nitrogen, I will have 2. So nitrogen, now count the formal charge. Carbon will have 0 formal charge, oxygen will also have 0 formal charge, and nitrogen will have 2 4 6, basically minus 1 formal charge. This is one Lewis-Dot structure. Another possibility can be you can form basically 2 bonds from this side. Are you getting or not? So if you form 2 bonds from this side and 1 bond from this, so basically what we have to do, we have to form 2 multiple bond, and this can be done by 3 ways. You can do by this, you form a double bond this side, and basically you can form a double bond this side, or you can form a basically triple bond this side, multiple bond, and this side. Okay, let me show you again. One can say basically where I have formed this structure. Now this lone pair can be used to form a next bond. Are you getting or not? So if I do this, this lone pair forms a bond. Now we will have this structure, nitrogen, carbon, and then here I will have 3 bond, and oxygen will have 2. Are you getting or not? And nitrogen will have 2 4 6. But now in this case oxygen will have plus 1 formal charge, carbon will have 0, 2 4 6, and this is 7. Nitrogen will have minus 2 formal charge. So this is not a good Lewis-Dot structure because there are too many formal charges. Are you getting or not? So this has too many formal charges. So we have already said The Lewis dot structure that has too many formal charges is not a good Lewis dot structure. This has a too many formal charges. Somebody can think, why you are making from this side, why not you make triple bond from this side? This is one electron goes from this side. So let us say, for no confusion, I can show you the same thing. So let us say the first structure, this structure, this one. So if you take this structure, nitrogen, carbon, and then oxygen, so I have 2 4 6, here I have 2 4, I think this is 6 also. So somebody can say, why not you make two bond from this side? So if you do this, what you will have carbon, and then you will have triple bond nitrogen, and you will have a lone pair, and then you will have oxygen. Now check the formal charges. 3 plus 2, nitrogen will have 0 formal charge, oxygen is 0 formal charge, and carbon will have 0 formal charge, and oxygen will have minus 1 formal charge. Octet of carbon is complete, oxygen octet is also complete. You see here 2 4 6 8, 2 4 6, and this is 8, so carbon is also complete. Now in this case, octet of each atom is complete, and this oxygen has only negative charge. So this is also a good Lewis dot structure. So we have two good Lewis dot structure. This is a good Lewis dot structure, and this is also a good Lewis dot structure. But these two Lewis dot structure are treated as a resonating structure. If you see in among these two which is better, so this Lewis dot structure contains negative charge on oxygen, and this Lewis dot structure contains negative charge on nitrogen. So preferably this will have a better contribution than this, because this has more electronegative charge on negative charge on electronegative atom. So that will basically part of resonating a structure. For our case right now, we can say these are two Lewis dot structure possible: Lewis dot structure 1 and Lewis dot structure 2, and 1 and 2 are basically resonating a structure. So we will stop here, and we'll do some more problem related to the Lewis dot structure in next video.